So we're now on to question 8 from the paper 1, and the first question gives you a diagram like so here. And it says in the first question that it says if this sphere has some radius of 12, now the centre of the sphere being O, that means O to A will be 12 and O to B will be 12. Okay, just so as we realise that from the centre of a sphere to any point is a distance of 12. And it says you need to find basically B to C. So you can see that C is a little bit below the centre of my circle and it pops on down, but it wants you to find B to C. And it says to do this you can find it in terms of X. So I've drawn the triangle over here just to give you a clearer picture of what's happening. So we essentially have this side profile here of this two-dimensional type now shape, and we know that O to B is 12. It says let O to C equal X, and then it says for that find B to C. So hopefully you notice we have a right angle triangle in there. So a right angle triangle simply says that we're going to be the hypotenuse squared, which is going to be 12, is going to be equals to, and then we don't know this, so what will we call this? We'll just literally call this BC right here. X squared plus BC to be squared. Okay, so with a small bit of rearranging, 12 squared is 144. X squared comes over, becomes a minus, and that's equal to my BC squared. But of course I'm not looking for my BC squared, I'm looking for my BC, so that means I must square root all this stuff. So that essentially is my BC. That's the first part. And then it says in the next part that show the volume of the cone is equal to this. So it wants us to get down to this pi over 3, 12 plus x to be squared, 12 minus x. So it gives me this and it says, can you show me that the volume of the cone is this? So first off, we would go to our logbook and we would write down the formula for volume of a cone, which is a third pi r squared h. So when we look at the cone side profile here, we can see that the cone, what you need for that, you need a radius of the cone, which is B to C. You need the height of the cone, which is here. So we don't quite have the height of the cone yet, but what we do know is that, as I said previously, that O to A is also a radius. So O to A here is 12. I mean, and if we're working in terms of X, we can say that H, which is the full height of the cone, is 12 plus that X. The radius, well, that's BC we just found, which is the square root of 144 minus x squared. Okay, so we actually have everything we need, so we can fill that in. So a third pi, now r squared, that is the square root of 144 minus x squared times the height, which is 12 plus x. Okay, so let's work on this because we have to get back to this answer here. So the squared and the square root will cancel, leaving us with this. So we're not quite there yet because we have this going on here, but what you might see is that 144 minus x squared is essentially 12 squared minus x squared. Yeah? And why did I do that? Because that's actually the difference of two squares, so that will actually factorize to this 12 minus x and a 12 plus x. And of course we can't get our other 12 plus x over here. And our third of pi at the front. So now, once we simplify all this, we're left with a third of pi, which is pi over 3 at the front. We're left with a 12 minus x, and we're left with two 12 plus x's. Now, two 12 plus x's is essentially what I'm looking for here. That's 12 plus x twice, or squared, and of course the 12 minus x. So we're down to there, okay? So that's the answer to the second part. Now, in the third part, it says to us that find the maximum volume of the cone in terms of pi. So this is the volume of the cone in terms of x. Now, whenever we see the word maximum, we know that we're talking about differentiating and setting equal to 0. So whenever you hear those words together, maximum or minimum, you must first think, we see the word maximum, or we see the word minimum, we're thinking of f prime of x, or dy dx if you like, equal to 0. This should be a mantra you have when you see the words maximum or minimum. So this is what we want to find out the maximum for. So this is the function essentially. So let me write it up here again. So our function that we're talking about is in x, so it's a function of x is equal to pi over 3 12 plus x to be squared times 12 minus x. So we want to differentiate this and set it equal to 0. Now you could of course differentiate this with the product rule, but I'm just going to do it a little bit slower to do a baby steps method. That's the way I like to teach it, and if you can do it the quicker way, so be it, but let me just do it this way first. Just baby steps. Let's multiply out these brackets. So pi over 3, now 12 plus x squared, let me square that again. That gives me 144, and that gives me then a plus 24x and a plus x squared times 12 minus x. So now I'm going to multiply out these here, these brackets, and I still have my pi over 3 out the front. And of course I haven't differentiated yet, so it's wrong to write that. I'm still in the function. So that is 144 multiplied by 12. 144, that's 1728. And then 144 times minus x, that's minus 144x. Now 24 by 12, that gives us a plus 288x. And then 24 by a plus by a minus will give us a minus. 24x by x gives us a 24x squared. And then the last term, x squared by 12 plus 12x squared. And x squared by minus x cubed. So I have all this stuff going on here. So let me tidy up the inside there. So let me put the bigger terms first. So I have a minus x cubed, and that's the only x cubed terms I have. A plus 12x squared and a minus 24x squared. That gives us a minus 12x squared. A plus 288x and a minus 144. That gives us plus 144x. And of course a plus 1728. Okay? Now I can just go ahead and differentiate this, but I'll just bring in the pi over 3 just to keep it tidy, right? So minus x cubed with a pi, I suppose I should have put that at the front. So minus pi x cubed over 3, that's that multiplied by that. Now that's then minus 12 pi x squared over 3. And then plus 144 pi x over 3. And then plus 1728 pi over 3. So now I've brought in the pi over 3. Is there any simplification I can do here? Well, not on the first one. The second one, 3 does go into 12 4 times. And now 3 into 144, yeah, 48. And 3 into 1728, and it's not going to matter, but yep, 576. So now I can differentiate this. So now I can write the f prime symbol as I'm differentiating. So 3 comes down in front and reduces the power by 2, so you get minus 3 pi x squared over 3. And then multiply by 2 minus 8 pi x to the power of now 1. And of course here we just drop the x. Okay? And these 3's just go as well, leaving us a minus pi x squared. But of course to solve this we need to set that thing equal to 0. Right? So far so good. I'm down this far, but now I have a quadratic equation, of course, equal to 0. So let me write that here. So I have a minus pi x squared. I have a minus 8 pi x, and I have a plus 48 pi equals to 0. I can actually factor the minus pi out like this, giving me this x squared, or then plus 8 pi, and then also we have a minus pi, so that's going to be minus 48, and that's then equal to 0. And so now I need to factorize that, minus pi, and that's going to be, so the factors of 48, so we have a plus 12 and a minus 4. So plus 12 and x minus 4 okay, equals to 0. So pi can never be equal to 0 anyway, so that won't work. So x is either going to be equal to minus 12 or x is going to be equal to 4. So which one are we going to use? Well, we can't use minus 12 because when we spoke about x, if you remember from the first part, we were talking about a length. So how could you have a length of minus 12? That wouldn't make sense. So your answer must be 4. So we disregard this answer and we accept this answer because we're specifically looking for an x. Okay? So that's not enough now for our actual answer. If our answer is equal to 4, remember the volume of our cone that we were talking about was this here. Was this actual equation here. So that's when we talked about our volume of our cone. Okay? So when we talk about our volume of our cone, we had an equation that looked like this. It said pi over 3 12 plus x to be squared times 12 minus x to be squared, 12 minus x, sorry. So this is a function for the volume of our cone. We figure out it's a maximum value when x is equal to 4, right? So let's put 4 in for x now. So therefore the max volume is equal to pi over 3 12 plus 4 to be squared and 12 minus 4. That's pi over 3 times 16 squared times 8, and add a calculator. So 16 squared is 256 multiplied by 8 equals to 2048. So I get 2048 pi over 3. And of course that was centimeters cubed. Like, it's important to never forget the units, because I mean you do need to have units to make your answer make sense. And if you do science, like you'd understand that, especially in like physics or chemistry or something, you'd know units are super important here, right? So that's the first part done. Okay, on to question 8, part B. So in question 8, part B, it says a water trough has a capacity of 112.5 litres. Its two ends are isosceles triangles. And you're given a shape like this that's open at the top, obviously. And here's a picture of the end. So they give you some dimensions for the end. So say it has 8x, 5x, 5x. And you need to find this length L, obviously, in terms of x, because if we want to show the internal surface area as this, well, we need all the measurements in terms of x. So how many sides are there? Well, there's the two ends and there's the two sides here. That's it, just 4 sides we need to find. So let's work on the triangle first. Now, in an isosceles triangle, if you take a line from the top, we would normally say, obviously it's the bottom here, down to the base. Because it's isosceles with both angles here being the same, you actually hit it perpendicularly halfway there, like that, right? Which makes two triangles. But the nice thing about hitting it halfway is you actually now, if I draw one triangle, like so, I know I have a 5x here, and I know I have now a 4x because I hit it halfway in a right angle. So how do we get this h? Well, I'll do that over here. H is essentially going to be gotten by Pythagoras' theorem, where 5x, being the hypotenuse squared, is equal to h squared plus 4x to be squared. Well, 5x to be squared is 25x squared. That's equal to h squared plus 16x squared. That means 25x squared. Now, this comes over minus a 16x squared is equal to h squared. That means 9x squared is equal to h squared, which means that square root of this stuff is equal to h, which is equal to, of course, 3x. So we know now that this is 3x. So what about the area of the triangle? So the area of the triangle. Well, of course, you may know well from junior cert that you're told half the base by the perpendicular height. This is this triangle we're looking at. So what's half the base? Now let's take this to be the base. Well, half of that base is going to be half of 8x. Yeah, the perpendicular height we just figured out to be 3x. So 8 by x by 3x is 24x squared, and half of that, 12x squared. So now we actually have the area for one of the end pieces, right? So I might say the area for an end is equal to 12x squared. Now we know the area. The next thing we need to do is find the area of these sides here, right? So looking at these sides is here can be a little bit tricky. Like you have L, how could you possibly get that length L with just knowing the area of the end? Well, you can't, but what the information you do know is this volume is 112.5 litres. Now, how do you get the volume of a shape like this? Well, I say it's a regular shape the whole way through those two isosceles triangles, which means that if you can get the area of this end, multiply it by the length, that gives you the volume. Now, personally, something which I think is incredibly unfair is that you may not know that 1 litre is equal to 1,000 centimetres cubed. We need our volume in centimetres cubed because that's the units we're working in. So again, look, I mean, I'm not overly happy that they'd ask a question like this because not all students are familiar with those conversions. Maybe if you do physics or chemistry, yeah, it's fine. But students that don't do that may not know this, right? So 1 litre is 1,000 centimetres cubed. So we know that this volume at 112 litres, and 1 litre being 1,000 centimetres cubed, then 112 by 1,000 will give you a volume in centimetres cubed. Now, why do we want that? Well, we know now that if we get the area of one triangle end, which we do, and multiply it by L, that should give us that volume. So we can make an equation. We can say that the area of a triangle, which we know to be 12x squared in terms of x, if we multiply that by this L, that should give us 112,500. Okay, so therefore L must be equal to 112,500 over 12x squared. And if you divide 12 into that, you should get 9375 over x squared for L. Okay, so that doesn't, we're not done yet because we still need to show the actual internal surface area. So now that we have L and we know the end, we know the surface area is made up from this. So surface area. So let's think about surface area. There's two ends and there's two sides. So we know the two ends. That gives us 2 times 12x squared, which is equal to 24x squared. So that's the two ends. What about these two sides? Well, let's look at the diagram. The sides are just rectangles with a length of L, which we know now to be this. So this is our L. And a height which goes slanted, which is this slanted height here of 5x. So the sides are going to be 9375 over x squared by 5x essentially. Okay, so that cancels with one of those, leaving us on the top with 9375 multiplied by 5 equals 46875 over x. And of course we have 2 of those, so we need to multiply that by 2. And that gives us a 93,750 over x. We do that. So that's our 2 sides. This is our 2 ends. So therefore, our surface area is going to be, our 2 ends, which is this 24x squared, plus our 2 sides, which is 93,750 over x. And if we look at what we were asked at the very start, that's what we were asked. We were asked 24x squared, 93,750 over x. So yeah, a slightly tricky one, I would say there. So now on to the next part, and it says find x for a minimum surface area and verify our answer. So we had a function for the surface area, which was equal to 24x squared plus 93,750 over x. So whenever we see the words minimum or maximum, I've said to you previously, you must think about differentiating set equal to 0. Take that as a small little mantra. I see the word minimum, I see the word maximum, I'm going to differentiate it set equal to 0. I'm going to look, where can I do that? I can do that here. I can go ds dx to differentiate this. That's going to go to 48x. And this stuff here can be rewritten as 93750, and when the x comes up, you can go x to the power minus 1. Therefore, the power comes down up front. That's minus 1 times that stuff, which makes it negative. And x is going to reduce this power by 1, so it's x to the minus 2. So, of course, that can be written a bit nicer as 48x minus 93750. Now bring this stuff back down underneath the line, x squared. And, of course, set that equal to 0 because we're looking for this minimum point. And it's also important to say, they do say verify your answer here. Now, I think I know what they want you to do, but like, this is a positive quadratic equation, which means it should be like a U-shaped type graph. So, I mean, you're going to have only a minimum point in a positive x squared graph. So, let's rearrange this to solve for x. So, what if we bring that over? And now we want to bring this guy up, so that'll make it 48x cubed is equal to 93750. That means x cubed is equal to 93750 over 48. It means x is equal to the cube root of that stuff, 93750 over 48, which is equal to, so where am I, shift cubes, 93750 over 48 equals to 12.5. So 12.5, and we're looking for x, so x is a length, so that's centimeters. And then, so I mean, how could you verify this? I'm not going to do it because like it can only have a minimum value. So how do you verify that's the minimum? Well, you could, I suppose, do the second derivative. And the second derivative, if you put the x value into the second derivative of this stuff, well, if it gives you a negative value, that means it's a maximum. But if it gives you a positive value, it means it's a minimum. But I mean, I'd be happy if I was the examiner that you told me that it was a positive x squared, positive quadratic, which is a U shape. I mean, I think, which can only have minimum. I'd be pretty happy with that. So there's our minimum value. And the next thing says, hence find L, the length of the trough. So we know L is equal to 9375 over x squared from the previous part. Let's see, do I have it? I don't, I probably threw it away somewhere. Oh yeah. So, if you remember, we sorted L out to here to be 9375 over x squared. So now we know our x to be 12.5, so that's 9375 over 12.5 to be squared over that there. And what's that going to give us? So 9375 divided by 12.5 to be squared, and that gives us, oh nice, 60. And remember, it's length. So that's that part done. Okay, we're on to the last part for this, and it says that water is poured in to this trough at 0.2 litres per second. Find the rate at which the depth is increasing when the water is 5 centimeters deep. So this is actually a very tricky problem. It's a rates of change type problem, but I'm going to suggest how you start all of these. See what you have first. It says it's water is poured in at 0.2 litres per second. That means you have the change in rate and volume with time. So I mean, you know the volume's increasing by 0.2 litres per second. Now again, look, we have to change 0.2 litres to centimetres cubed. So essentially that's going to be 0.2 multiplied by 1000, okay, which is going to give you 200 centimeters cubed per second. So actually what the question gives is a change in volume with time. So this is actually a dv dt, okay. But what we're looking for is find the rate at which the depth is increasing. So looking side on at our trough, we can see this triangular shape, which we figured a lot about already. We actually want to know how deep the water is going to be. So we need to figure the rate at which that's getting bigger. So we're looking at the change in height, say, with respect to time. So essentially what we're looking for is dH dt. And what we have is dV dt. So what we're actually looking for now is we're looking for something that's going to keep our dt but get rid of our dv, and it's going to give us a dH on top. So there is a video on rates of change which I'll do, which I'll link as soon as it's ready. But we're looking for this unknown quantity here, which is a rate of change of some sort. So, well, we want to keep dt because that's in the answer. So obviously dt is not going to go, but dv needs to go. Now the only way dv is going to go is if I multiply it by something with dv on the bottom, because that would cancel. And we need a dH on top. So what you can see is that when I make this equation, this is a number that I know. This is something I don't know. I actually need dH. I need an equation, sorry, h in terms of v's. Now, I know something about this whole thing. I know an equation for actually the volume here of this water trough. And how will I get that equation for the volume? Well, I know that the volume depends on two things. It depends on the area times the length. Yeah. So the volume is going to be the area of this triangle multiplied by the length. Now the length is a quantity that we know because we figured out already that the length was 60. But the only problem with getting the area of this triangle, which makes it hard, is we actually have to find y in terms of h, because the volume of the area of this triangle depends on two measurements: half the base by the perpendicular height. But of course, if the height changes, so does the base. So as your height goes down, your actual base comes in. So you actually need it in one variable. So we're going to need to get some way. We're going to have to change this y to h stuff. And how do we do it? Well, I've put in the measurements that we know. We know that if we look at these heights the way it is here, basically, that h in terms of y will be the same as 37.5 to 50 in a ratio, and that's using similar triangles. So using a similar triangle rule, we can say this. We can say that, match these up, we can say that what we're looking for, h, so we can say h over, oh sorry, we're looking for y in terms of h, so y over h. So y over h should be the same as 50 over 37.5. And with a small bit of rearranging, obviously, then we can say y is equal to 50 and bring up our h over 37.5, and that actually simplifies to 12 and a half, don't they? So that should simplify to 4h over 3. So actually we can say for our triangle, instead of this y here, we can say that's going to be, that's always equivalent to 4 times whatever that h is over 3. So definitely a hard part to get. So now, looking at our volume equation that we have now, and I'll work on that here. Therefore the volume is going to be the area of a triangle, which is going to be half the base, yeah? So what's our base going to be there now? Well, it's going to be, well, I'll tell you what we'll do. We'll say half the base, and let's actually use this one side of this triangle here, right? We'd have to double this, because if I double this, half the base is going to be the full lot, and if I know y is equal to 4h over 3, well, the base technically is equal to 8h over 3. So let's just work on this triangle here, and let's double our answer. So we'll do 2 times it. So a half, 2 times a half, whatever. The base. So the base is going to be a whatever 4h over 3 here now, and of course the perpendicular height is going to be h, which is this h here, and we're multiplying that then by the length, which is 60. Yeah. So I have my volume equation now in terms of h. So a small bit of tidying up. These will go, and now I'll have 4 times that is, so a 4h squared, I'll do this a bit slower, over 3 times 60. Now this recants 60 to be 20. So essentially my volume equation is 80h squared. Therefore V is equal to now our 80h squared. So therefore we can get dV dH to be 160h. So now we actually have a quantity for dv dh. But of course we're looking for now a dh dv. So let's see what we actually have here for the minute, right? So when we're looking for our dh dt up here, we can say dh dt is equal to dv dt, and we know dv dt to be this quantity here of 200. Now what about dh dv? Well, we don't actually know dh dv, we know dv dh, but we know that dh dv is the inverse of that. So we can actually say that dh dv is actually 1 over 160h. Now again, look, this is something that you will get used to with your rates of change type stuff. So dh dv is equal to 1 over 160h. So let's multiply that by 1 over 160h, and that gives me, of course, so some of these will cancel, so let's get rid of this first, the zeros. So 4 goes into both of them, which gives me a 5 on the top, and it gives me a 4 on the bottom with a h. So we actually see that it's going to be dh dt is going to be 5 over 4h. Now what's going to happen, of course, when that is going to be, when this h is going to be 5. So when this h is going to be 5, so at a h equal to 5, y equal to 5, because it says find the rate at which the depth is increasing when the water is 5 centimeters deep, or when this is 5 centimeters high. So that would imply then 5 over 4 times 5, which just gives me actually a quarter. And what's changing? Well, the depth is increasing, so the height is increasing. So that's going to be a dh dt, the height per time, so that's going to be in centimeters per seconds. So a quarter centimeters per second, or if you like 0.25 centimeters per second. Probably one of the harder questions you're going to solve there, but I suppose when we break it down by time and with some practice with this rates of change stuff here, which is what this is, right? So if you're looking for similar questions in your book or in other chapters, well, this is a rates of change type problem. Okay, and that's that question 8 then done.